Good morning, students. Today we are discussing an experiment called compound pendulum. This experiment name is compound pendulum. The main aim of this experiment is to find the acceleration due to gravity at a given place. The apparatus are stopwatch and metal stick and rigid support. These are the apparatus. So first of all, we have to calculate acceleration due to gravity. We are using this metal bar. This metal bar contains how many holes will be? 19 holes will be there. So each hole, the distance, the gap between each hole is 5 centimeters. So now we are keeping this screw and we are fixed like this. Okay, let me explain what is meant by oscillation. So what means by oscillation means it's a to and fro motion. So when this is a pendulum, and for example if you are moving from here to here and again come back to this is called oscillation. To and fro motion is called oscillation. So for example if you are starting from this position and again come back to this position, then this is called oscillation. So this is called stopwatch. So now this is the pin we call set pin and this is called reset pin. For example, if you are on, it will be starting position from here to it is start like this, and this is the position we have to stop. Okay, and this is the pin called reset button. When we press like this, again it comes back to its original position. Now we want to calculate oscillations. Okay, the time taken for 20 oscillations. So now this is the starting position and we have to start from here and again we have to count for 20 oscillations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have to stop for 20 oscillations and we have to note the time. This experiment will be repeated again for the same length. Again we have to calculate. At exactly at 50 centimeters, we won't get any oscillations because at this 50 centimeters the center of gravity is acting. Now see, we are keeping this pin exactly at 50 centimeters. Okay, now we are inserting and we check whether it will oscillate or not. Yes, see here you won't get any oscillations because at exactly 50 centimeters the center of gravity is acting, so we won't get any oscillations. Okay, now we will draw the graph between length and time period. So length we are taken on x-axis and time period we are taken on y-axis. Now according to the values we have to draw a graph between length and time period. And we have to draw one straight line like this. In this line, okay, which touches the 4 points. This point A, B, C, and D. Now we have to consider the 4 points A, B, C, and D. Okay. Now we calculate length by using one formula L equal to AC plus BD by 2. Here AC how we calculate means the difference between these two. 65 minus 20, that is the AC value, and BD value is nothing but 90 minus 35. So that is the BD value by 2. Then you will get the length. Now we will put AC value and BD value by 2. Then you will get this plus this by 2, you will get 60. Now the formula is L by T square. Now this is L by T square. That L value is 60, by T square value is this 2.56. Okay, after solving you will get 23. K is equal to root over AG into GC. Now from the graph, AG value is nothing but the difference between this A point and this is the G point, the difference between these two, that will give you AG value, and the difference between G and C, okay, will give you GC value. That means G value is 50 and this is 70 minus 50, then you will get that one value. After that, if you calculate, then you will get some radius of gyration, you will get some value, okay, that is in centimeters.